All right, first problem I'd like to work on is the number one from the test, the area between two curves. And the reason I had you make the graph is because that becomes real important. I'm going to make up a new problem for us, and it's going to be, come on, y equals 2 cosine pi x divided by 4 and 0.5 times the quantity x minus 2, 0.5 times the quantity x minus 2 squared. Okay, so those are those two. Then I'm going to hit zoom 4, and here's a graph. Now, I need to know there's this area between the two curves, and I need to know where they intersect. And I can go to second table set and set my x start at 1 or start at 0. I'll leave it there. Changes by 1, and I can go to my graph, and if you need help plotting this, you can go second table, and it'll give you values to plot for 1, 0, minus 1, up and down for both graphs. And we can see on here that they intersect at 2, 2, at 0, 2, I should say. When x is 0, both curves are 2, and when x is 2, both are 0. You can also find the intersection points. Again, that's really important for this. To be able to do this, you can go second, calculate the intersection point, and it's on the blue curve, and it says, is that one of the curves? And you press enter. And then it's on the red one, and it says, is that the second curve? And I press enter. Then it says, move close to my guess. Well, that's one of my guesses right about there. And it says, yeah, 0, 2 is where they intersect. And then I can go second, calculate the intersection. And is that one of the curves? Yes. I press enter, go down, and the blue curve, is that one a second curve? Yes. Then I'm going to move close to one of my, where I want to find that one, and I'm going to press enter. Oh, second curve, yes. Oh, second curve. There we go. And that's my guess. And it says, yes, 2, 0. So you have to get, say, the two different equations have to show up here for you to get the right, and then you move close to where you want to find the intersection, and we'll find that intersection for you. Okay, so I'm going to make a quick sketch here for this, and it was, they intersected at 2, 0, 2 and 2, 0. One of them went this way, and one of them went this way. And this one was the cosine curve. You can take a look at the graph on it there. It was y equals, I'll look it back up here, 2 cosine of pi x over 4. The other equation was y equals 1/2 or 0.5 times x minus 2 quantity squared. So, now that I have that, let's see, why did that go to there? Okay, well, that's all right. I have my intersection points, and the way you find the area between them is you find the area under the top one minus the area under the lower one. So the area under the higher one would be all of this, and then you subtract the area under the lower one would be that, and that will give me the area between them. And to find the area under a curve, you find the integral, and you take a slice, and usually when we're doing area, we'll do it vertically. So if the slice is vertically, its thickness is in the x direction, so it's dx wide slice. The height of it is in the y direction, and it goes up to the curve, which is the y value, but we're doing integration by x, so I have to use what y is equal to in terms of x, and that's this, 2 cosine pi x over 4. And I want to find the area under this curve when x starts at 0 and gets clear up to 2. That's where they start to be intersect, and then that's where they end. Now, then I have to subtract the area underneath the other one, which would be also from 0 to 2. It would be a slice, this vertically, and the width of the slice would be dx again, and so the height is also y, but I need to have it in terms of x, so I have to use this equation, 1/2 x minus 2 quantity squared. So this is what I have to work out. Now, you can put both of these into the same integral, but I'm going to leave them in separate ones here. So, now I'm just touching my phone because I'm using my phone and it sometimes dies on me here. Okay, so now, to do this one, this is not just a simple x. You don't integrate this and then integrate the cosine separately. I saw several people in the test do that. If I had to take the derivative of cosine of pi x over 4, to take the derivative of this, I would have to take the derivative of the cosine. Derivative of cosine would be negative sine x, or sine of whatever was inside, and then I'd have to take it times the derivative of the inside, and the derivative of the inside would be pi over 4. Pi over 4 times x derivative is just pi over 4. So when I'm taking the derivative, I get an extra pi over 4. If I were taking the antiderivative of this, then I don't have this pi over 4, and so I have to divide out the pi over 4. But let me show you another way to think about this. Do the u substitution. Let u equal pi over 4x. Then du would equal pi over 4 times dx. And then I would have to multiply both sides by 4 over pi would equal my dx. And so this would become not 0 to 2 anymore. It would be new ones because I've changed to u. I have a 2 that's times the inside. It's a constant, so it would pull out, and I'd have the cosine of u, and I would have dx would change to 4 over pi du. The 4 over pi is a constant. It would pull out, and I would have 8 over pi integral of cosine u du, and the limits I don't know because I didn't change them. Integrate the cosine, and it's sine, so I get 8 over pi sine of u. It evaluated from something to something, but now I need to change back to my x, which is going to be 8 over pi sine of pi over 4x. Now it is an x, and so I'm going to evaluate it where the x limits were from 0 to 2. And when I do that, I put in the 2, and I get 8 over pi sine of 2 pi over 4. Uh, 2 over 4 reduces to 1/2 sine of pi over 2 on my unit circle. Pi over 2 is here, and the sine is 1. So this would be 8 pi, and then I have to subtract putting in 0, and I'd have 8 over pi sine of 0. And the sine of 0, the y value at 0, is 0, so this goes to 0. And so for this first part, the area under all of this would be 8 divided by pi minus 0, or 8 divided by pi. That's all of the area. Now I need to subtract what's under the other one. Now I can do a u substitution for the x minus 2, but I could also, well, okay, let me just do that. So now we have to do the integral from 0 to 2, and I can pull the 1/2 out, and I'm going to let u equal the x minus 2, du would equal dx, because derivative of x minus 2 is just 1 dx. So this would be u squared du, because du is dx, and this is the u. Now it's no longer 0 to 2, because I'm in u. When I integrate u squared, I get, I have the half outside. I raise the power by 1, so that's 3, and divide by 3, so I get u to the third over 3. And I have to evaluate that from something to something. Changing the u back, I would have 1 over 2 and x minus 2 to the third over 3. And now I'm back in x, so I can use my old limits, which were 0 and 2 that we got from the graph. That's what x goes from. We're doing dx, and x goes from 0 to 2. And so I put 2 in here, and 2 minus 2 is 0. Cubed, doesn't matter because it's 0. So this whole thing becomes 0 when I put 2 in. Minus, put 0 in, and I get 0 minus 2, which is minus 2. Cubed is negative 8. So I get 1/2 negative 8 over 3. The 2 would reduce the 8 to negative 4. And I have subtract the negative, which is plus 4 over 3. And that's the area under this curve. So the area between them would be the 8 over pi minus the 4 over the 3.